Okay. Hi, my name is Daniel Kornev. I'm Chief Product Officer at DeepPavlov, and this is like our 12th community call. And sometimes we get a lot of people, sometimes we get just a very few people like today. Usually we have different kind of agendas on our community calls. Sometimes we focus on the products we're shipping. Sometimes we're talking about learnings we made from our experience participating in big challenges like Amazon Alexa Prize. Sometimes we get outside speakers who tell stories about their work in the NLP and conversational AI field, and so on. So today's one is going to be focused on our learnings from Alexa Prize 3. And this is the second part of our series about our product learnings. So in the first video talks that we had a couple of months ago, we stopped talking about the key tenets that we have chosen for Alexa Prize 4 in our team prior to building an application for the competition. And these are the tenets. They start with the idea that we need to have lots of contents in the system, lots of contents, and we don't just want to have contents, we want to have structured contents. And before talking about structured contents, it might be very useful to remind you about the purpose of the competition. As well, there is a Turing test, which allows you to talk to someone and then figure out whether that person is a human being or a machine. Well, Alexa Prize is quite different. And every user in North America who has Amazon Echo device and can say, let's chat, will get introduced to one of the social bots participating in the challenge. And this will allow user to have an interesting, hopefully, conversation with the chatbot, and then user will be asked to provide a mark rating to the social bot with the question whether user wants to get back to the same bot or not, and what kind of rating would it give to the social bot in question. So this competition is very long. The FACTOIDS finished just about a couple of weeks ago. And the big goal is to make a social bot that would get rating at least 4 out of 5, and that will sustain an interesting, engaging conversation on different topics for at least 20 minutes. What's interesting is in the past 5 years now, none of the teams managed to achieve the result. So, for example, in the first 3 years, there was steady. Maybe not that steady, but there was some increase of the rating. But the amount of times that social bots managed to keep in the conversation was like 7 minutes, 32 seconds, like what happened to our winner of Alexa Prize 3, Umora University's Umora social bot. But they managed to get a rating of 3.8 in Alexa Prize 3, which was quite alarming and quite interesting. In Alexa Prize 4, however, social bots managed to sustain up to more than 14 minutes of conversation with the user, but the ratings dropped back to 3.28, which means that the challenge of having a conversation lasting 20 minutes and having a rating 4 out of 5 is still out of reach. And it's still a big challenge for us. Even after 5 years, Amazon is running this competition. And for us at DeepPavlov, this challenge is twice as hard as for all other teams, because all the teams, including ours, are provided by Amazon Cobot framework that allows us, our teams, to build an entire social bot using Amazon technology. And then teams are free to use any kind of technologies they want to incorporate into their social bot to further extend it and enhance it to win in the competition. But in our case, we decided to use our own technology, DeepPavlov agent and DeepPavlov library, in order to build a social bot for Alexa Prize 3. And this meant that we had to struggle with not only building a great social bot itself, but also adapting our technology for running in production environment 24/7. When the team that is supporting this whole premise is just students, be it graduate and undergraduate students. And that was really challenging for us. And last year, we achieved level of like semifinals. We didn't get into the finals of last year. And once we stopped participating in Alexa Prize 3, we started like open sourcing the whole thing. We spent about 4 months. We put a lot of effort into adding our own knowledge-based question answering technology to support factoid questions in our social bot. But as soon as Amazon announced Alexa Prize 4, which happened on September 9 of last year, we started thinking, what are the key directions that we want to put our limited energy and resources into in order to move forward and get into the finals of Alexa Prize 4. And we've learned many things from our participation in Alexa Prize 3. And in the end, we ended with these tenets, which more or less outline not only what we actually started to work on in our Alexa Prize 4 social bot after being chosen to participate, but also outline the direction for where we are going to go in the next versions of the social bot beyond Alexa Prize 4. And okay, and in the last talk that we had like a couple of months ago, we've ended with these tenets, which are focused on topics, entities, relations, and actions, world, user, and bot graph, and focus on topic and entity-based templates. And here, I believe it is important to start with the last thing, because this is very crucial, very important for us. While there is a lot of passion from the industry to use GPT, like GPT-3 and other systems to control dialogue with the user and provide something interesting, something engaging, and so on. Nonetheless, when you try to actually build interesting open domain dialogue system that can engage user in a fantastic conversation for a long time, you will get into trouble. And the trouble I'm talking about is something that I would like to quote from an article I've read preparing one of the papers in a lab a couple of weeks ago, or something like that. So let me put it this way. Yeah, this is the source code. So when GPT-3 was published to the market, there has been done some research, the so-called GPT-3 complete tests. And folks from those GPT-3 complete tests, they made a fantastic quote. Professor Samet Stay from one of the universities on the East Coast of United States, he said, GPT is odd because it doesn't care about getting the right answer to a question you put to it. It's more like an improved actor who is totally dedicated to their craft, never breaks character, and has never left home, but only read about the world in books. Like such an actor, when it doesn't know something, it will just fake it. Now, this is maybe a more beautiful way of saying about the limitations of generative models, but in our own experience, we learned, and by the way, in this case, in Alexa Prize 4, we used BlenderBot, which was built by our friends from Perlite team from Facebook AI Research. But what we learned in general is, while large generative models, they can provide an illusion of a meaningful conversation. In general, this conversation is lacking consistency, lacking proper use of context, and can lead to fails in the conversation. So for example, if you talk to a generative model and you say something like, I like green color, and it would say something, oh, I also like it. And then like in next few steps, you will come back and say like, what color do you like? And it would say something like, I like blue color, or it might say, I don't like colors at all. And the problem is that it is unable to maintain context over a long time period. Sometimes it can maintain it over a very short time period. And it means that you basically cannot rely upon a generative model because it cannot maintain context, because it cannot be consistent, and it will break the illusion of meaningful conversation as soon as the context is going to be broken. And the BlenderBot that was built by Perlite team in last year, it was able to maintain context maybe in like 7 conversation turns, up to 7 conversation turns. In our tests, it didn't manage to maintain even that. So the biggest decision we made in last year while preparing our Alexa Prize for application was that we cannot rely on generative models, but then we need to rely on good content. And for that, we need to focus on 2 big things. One is topics, and second is entities. Okay, so let's dive into topics and why they are important. Why topics are important? So, like, what we can think about the topics themselves. Topics can be seen as, if you could look at the whole dialog as some sort of a tree, and some sort of a tree, and that in that tree we could go in some direction, and so on and so forth. And we can have lots of different branches, right? In each dialog moment, we can go to different branches and so on. So the thing is that we can see those kind of branches covering some particular topic. So for example, we can talk about music, then we can go to movies, or we can actually go to people. We can talk about musicians. And then because we talked about a particular musician, we can go to a movie where this particular musician participated in. And then we can go from movies to, I don't know, to books, or maybe to places in the world, because this movie was related to a particular place and featuring that place and so on. And in the end, this is how an actual casual conversation looks like. We have different topics and we switch between these topics, and we need to have something similar in the social bot if you want to have an engaging conversation. Why I'm talking about this is simple. When you build a social bot, you build a system that is basically designed to answer user questions at each step. So it's a step-by-step system. At each next step, it has to make a decision how to respond to user's utterance. And because it is an open domain system, user can basically say anything. And because user can say anything, we have to somehow be able to respond to any kind of response. Obviously, we want to find ways to limit to whatever user can say. For example, we can ask closed questions, and then user will provide closed answers, and that would alone allow us to control the dialogue. But this would happen at expense of user having not interesting conversation, because if you like involve user in answering only yes and no to all the questions asked by bot, then this is not an interesting conversation, not an engaging one. On another side is because we make decisions at each step, there is a lot of desire from social bot designer, if you like, to adapt to each single user utterance. But if you try to adapt to each single utterance, you don't think strategically, you don't think across multiple steps. You think about each particular step. And it is easily possible to use, even by the way, generative models to build a system that could work this way. Like you have a dialog, you have the steps, and at each step you would just say user said. So this is a user, this is bot, user, bot, and the like. So user said something, and we answer. Then user says something again, and we answer once again. And the thing is, when we design the whole thing this way, we can try to address each user utterance, isolated, without context. And then we don't care about topics. But this, as we learned from our Alexa Prize free participation, our experience doesn't build an engaging conversation. However, when you stop seeing each utterance out as its own, but try to see it in the context, then you realize that you need topics. And this was obviously proved by other folks from other Alexa Prize teams. They all like use topics, and we obviously had to cover topics as well. The question obviously was how to do that. Here are some of the key ideas we came up in last fall. So it's almost like a year now since the moment when we started working in the field, working this space. If you look at the conversation as a list of topics, then each turn can cover one or more topics. And if our step is covering more than one topic, is because user tries to switch topic from one topic to another. So we talked about movies, and we want to move from a particular movie to an actor. And we have to identify topic of each step, because if we are able to understand where we are, then we can control the dialogue. If you don't know the topic, then we cannot control the dialogue. And that was like very obvious idea. The second thing was we need to be able to track the topic within the conversation. And speaking from our Alexa Prize 4 experience, this turned out to be way more complicated than we thought. So for example, Cabot, which is Amazon framework provided to Alexa Prize teams, has a classifier called Cabot Dialog topics and Cabot topics, which is designed to detect high-level topics from each user utterance. Now, topic modeling itself is a well-known technology and field in itself, and it's widely used in different enterprise knowledge management systems and so on. But it is useful specifically because it can work with large documents in their corpora. But in the dialog environment, this experience is very different. So user says like, hello, how are you? And that's about it. You have to figure out the context about it. You have to figure out the topic about it. And there is obviously no topic here. Now, when the user starts, let's talk about, like, I have heard a beautiful music, like, for example, the White Buffalo's music we just listened to in the beginning of this talk. And I loved it. Here, it's more or less easier to recognize the topic of the current utterance of user. But then, for example, we would say, yes, it's super lovely. And user would say, yeah, I agree. Now, where this year I agree would have to go. The topic classifier would fail at trying to identify topic of this particular utterance without knowing that before that we were talking about music. And this means that whatever topic classifier we want to build, it would have to take this context into account. So tracking the topic turned out to be way more complicated. We made different approaches to that. We made one of the approaches in this summer and with one of the interns, and we still want to continue working in this area because this is a challenging task. Another idea that we came up with was that if we understand what the topic is currently being discussed, then we want to change it only in 2 cases. If user, okay, 3 cases. The case number 1 is if user no longer wants to discuss it. And reason number 2, if we can no longer continue discussing it. And reason number 3, if we as a social bot want to discuss something else. This is by the way challenging because social bot doesn't want anything unless it is proactive. So like reactive system obviously would just do whatever user wants, but that would not make discussion engaging. So the social bot has to have its own wants and needs to propose new topics to discuss. And for example, if I'm not mistaken, Emory University's social bot from Alexa Prize 3, they used teleportation as a subject, as a topic that was of interest for the social bot itself. And at some point, if the social bot would compute that there is a like small distance between the current topic and this teleportation topic, the social bot would try to engage user with a conversation, about the teleportation and social bot's interest in the teleportation. And that would make conversation with more social bot more interesting, because then the user would see that social bot has some own interests. And by the way, Emory University managed to win Alexa Prize 3, which was quite interesting. The third thing, obviously, is we also need to measure interest of user to a particular topic and attention to it. And we made a couple of experiments during the Alexa Prize 4 competition with profiling of user interests. And I believe that we will have to continue working in this space for Alexa Prize 5 if you'll be lucky to be chosen once again to compete. But this is also very important. The third big learning we made was that we need to learn a lot about the reasons why topic is interesting to user. Like we have to ask questions, we have to clarify details, and we have to ask opinions. And while this looks like a very simple suggestion, it's really not easy to follow through, because we have to design a skill in such a way that it would ask these questions and still be able to recognize whatever user is saying. And in the end, we managed to build the entire dialog flow framework as a mechanism to rapidly design and develop and build scenario-driven skills, where we could actually use this recommendation. So this actually went to our DFF framework. The final thing is we decided to keep track of topics that we used in the dialogue with the user, and make sure that if we are coming back to a different topic, that if we went back to the topic in the past, if we talked about this topic in the past, we can still get back to this topic if user expressed enough interest to it. So we don't have, what is important here is we don't have to go through only a selected number of like scenarios that we support, but we can go back to previous scenarios covering different entities, as long as the user expressed interest in those particular topics. Okay, so we can look at topics as a graph of sorts. And then we can think of the dialog as a system where we talk about any particular topic. We have designed at least 3 to 5 turns of directly discussing it. Adding generic or non-generic, basically, it's better to have non-generic opinions about the subject or the topic and be able to respond with several phrases. Now, this thing about responding with several phrases, it's coming from 2 different sides. One of them is if you want to understand better what you want to say to the user, you can respond not with one phrase, but give several phrases to give like deeper context to the user, so that user will have more things to respond to. And on another side, you obviously also want to have multiple ways of saying the same thing in your scenario-driven skill, so that if you would get into the same scenario path, you would at least have some variability to provide freshness of content to the user. Another idea that we wanted to explore, but we didn't manage to explore in our lecture prize for social bot, was the idea that we need to use connections between different entities within the topic or across different topics to dig deeper into the topic. So, for example, if you talk about Seattle, we can talk about the Space Needle, and we can discuss how user like different people can visit this particular location and talk about a very particular point of interest in this location, and then we can transition to something else, like to big companies living in Seattle area and so on. We actually didn't use this as much as I would like us to use, but this is one of the directions for lecture prize 5, I would put it this way. And another idea was that we can use topic switching by using these connections between different entities belonging to different topics to switch to different topic. So instead of talking just about, for example, pets and having a small scenario about pets, we could then make a slight shift and talk about cats. Then from cats, we can move to dogs and so on. And the interesting thing is, if we can generalize conversation about particular objects, and we can use those connections between different categories, then we can sustain longer conversation within the same big topic by using these connections. Another very important aspect is ability to acknowledge that we understood user. So the thing is, in reality, none of the dialects are ideal. People misunderstand each other. They might have problems with hearing, they might have problems with pronunciation, they might be interrupted, and then they might struggle with getting back to the context of whatever they've been talking about in the dialogue prior to the interruption and so on. And what people do to repair the dialogue, as long as they want to repair the dialogue, which is not always a thing, is they acknowledge each other. Oh, and by the way, they might not just understand each other, because the topics that they're talking about, one person might be more knowledgeable and the other might be less knowledgeable. But to express understanding, they can use an approach called acknowledgement. And it's very useful, like Gundrock, which won Alexa Prize 4, and Alquist, which, by the way, won Alexa Prize 4. They all use this acknowledgement to help user. So in Gundrock, to the toe, they specifically said that this is a mechanism of signaling understanding, and that it is a key aspect of human conversation. And the thing is, this acknowledgement can look different. It can be yes, no, yeah, sure, aha, and so on. It can be emotional, like cool, fantastic, and something like that, but can also be more complicated. Like, what is my mother's name? I don't know what your mother's name is. And if this acknowledgement is more specific, then this can create a sense of better understanding of user. And you can see Gundrock, they used role-based approaches and Blender from Perla as well to build these better acknowledgements. Another side that we wanted to explore was not just talking lightly about subjects, but also try to dig into like philosophical side of it. So, for example, it could be questions like why, right? So, what do you like to do? What do you love to do? I love hiking. Why do you like it, right? And the thing is, if you would just say, where do you usually go to hiking, right? It would give you some high-level information, like I go to Mount Dickerman like near Seattle and so on. But if you would ask, why do you like it? User would say something like, helps me to relax after tensions at work. And now you've got more content to work upon. You can ask like, what do you do? What is your work? Or like, tell me more about it, or sorry, and provide some emotional feedback to the user. And this could enhance your conversation, could make it more engaging, more interesting, and provide depth to the discussion, which otherwise would be lacking from the discussion. Another aspect is we could also say something that I called like philosophical statements. So it's like quotes from favorite people, and those quotes, if you don't use them so often, they could actually like ignite some spark in your user and make them more engaged in the conversation, and maybe even come after the conversation to ideas that they really enjoyed conversation because that made them think differently, look differently at whatever they were working on, building or experiencing. Yet, obviously, it is important that if you like are philosophical from time to time, it's still important to get back to the user's topic and continue conversation as it is. Another side that we explored a little bit in our Alexa Prize for Social Bot was idea of reflection. So imagine that you are being asked like, what is the temperature outside? And you think like the temperature outside is 20 Celsius and windy. And if user would ask you, which city are you talking about? If that would be a goal-oriented skill, you would probably just prepare intent that would answer this kind of question. But in open domain conversation, you cannot create intent for all kinds of things in a way. Yet we can have enough context in the system itself so that we could generate this context in code to make sure that we can provide the user with the information about that. And then I can actually even show you some of the code that we had in our system. Okay, so this way. So by the way, we are open sourcing finally our Alexa Prize for Social Bot. It is going to live in our repository deepnik/dream at GitHub. And once we will make the necessary factoring, it will be the main open source multi-skill AI assistant living in our Dream repository. For the time being, it's living in the Common B. It lives in Common B branch. And I can show you the skill that's called grounding. And this grounding skill is able to answer different kinds of questions, like what are you talking about and so on. Whatever the moment when user is trying to recover conversation by asking those questions that can be sort of reflective, we would go with this kind of answers, like I was asking you about something unknown for me stuff. That is very common response or something like that. But then we could go in deeper, like we could say, we are discussing this entity, or we are discussing this particular topic. And this allowed us to provide the user with information about the context as our bot is understanding it, and helping user to repair conversation by using this kind of mechanism. Okay. An even better idea would be obviously to be able to respond to contextual questions like, what do you think of Fortnite? Exciting game, extremely popular. Which game are you talking about? Fortnite. Or like second wave of COVID-19 is expected. Which region are you talking about? New York City.
This might answer your question.
Alexa, shut up. Thank you very much. Okay, so this is an idea that if we would provide this kind of reflection, it would help user to get back to the grounding of the whole conversation. However, this is alone is not good enough to provide an engaging conversation. So obviously content is still the king and still something that we need to focus a lot of our attention on to. Another learning that we made was that our system has to be focused on not talking about facts. Now, this might look very trivial for you right now, ironically, but in our Surprise 3 social bot, we relied a lot on facts and answers that Kabot QA specific service provided by Amazon to all Surprise teams. We relied a lot on it to provide user with some kind of a response. And obviously, it would give you, it would give to user some kind of factoid questions, factoid answers, and people just basically don't get involved into casual conversation because they want to get information about facts. For facts, you basically can go to Encyclopedia or like Wikipedia and get answers from there. But if you want to have a casual conversation, you don't want to do that. And back in the last fall, we thought about this a lot, and we looked into the experiments made by Alquist and Umori University, and all show that when you have lots of opinions made by a social bot and less trivia, you'll get an increase in ratings. Now, for Alquist, in version 2.0 of their social bot, the difference was not big. But for Umori University, it turned out to be quite a big difference. Okay, as a second tenet I want to talk about today, so probably a couple of things as well, is entities. So we talked a lot about topics as a mechanism to structure conversation and to see it as a sequence of topics that people and the social bot are discussing. And obviously, when you want to talk about some particular topic, you don't talk about abstract things. You talk about things, and those things are entities. And we need to be able to identify entities we're talking about, and then design the conversation around them. As, however, it was said before, like a couple of slides ago, it's not about facts about those entities. Again, we are not a question answering machine. We're trying to have an engaging, interesting conversation with the user. So in this case, we wanted to support conversation in around those entities, ask opinions, user a relation to those entities, and so on. So in a way, what was proposed was to think about topics as events. These events have entities, existing entities, new entities. We have relationships that happen, that exist between regional entities and the new ones, and we can track entity state progression over time. And in this way, this would allow us to see this aspect of conversation like this. Chunks of conversation as something that is a combination of topics and entities and their progression, relationships between them, and opinions about them, and maybe facts about them, and users' relationship towards those entities, and so on. And while we managed to get some good progress with entities and different skills that we designed for Surprise for Social Bot, one of the aspects of it we wanted to have was be able to discuss those entities from different points of view. And we wanted to add own opinion, maybe share own theory about things, infuse interesting facts, and so on, to make the conversation more interesting, more engaging. We, as a result, we actually built a bot persona skill that is able to provide a generic, more or less generic opinion about different things, but not like I like it or I dislike it, but like a relation of a bot to that particular entity based on the bot's persona. So, for example, our bot likes like 20 objects that were collected after looking into the data collected from the conversation between our social bot and the users. We picked like 20 top categories. For those 20 categories, we picked key entities. Then we designed social bots persona around those in such a way that we got a favorite object for all of those 20 categories. And then we extrapolated relationship between this bot and those 20 categories and made a computational approach so that when a user would ask, like, what is your favorite movie, we could say something with Harry Potter. But if they would say, what do you think about Master of the Rings, we would probably say that we like them. And if we would be asked, why do we like Lord of the Rings or Master of the Rings or whatever it is, we would say that we like fantasy movies. And that itself comes from the persona of the social bot that actually has this built into itself. However, we did not really focus a lot on this kind of area. So I would put this as one of the possible directions for Alexa Prize 5. Alexa Prize 5 as well. Yeah, and I don't want to go to the world graph today, but I again want to show what we actually have got to work on with entities. So before that, yeah, I still want to talk a little bit about entities for the world graph. I don't want to go into to other graphs like bot graph and user graph, but the world graph is important. So what the entities are? Obviously, if you like go back and look into the named entity recognition technologies that are going back to like last 20, 30, 40 years, something like that, you will have a few kinds of entities that you want to extract from the text. It can be organizations, it can be people, events, locations, and then you have something more easier like dates, times, and maybe money and something like that. Now, when you look into projects like what Microsoft worked like 15 years ago called Windows Future Storage, WinFS, they were designing hierarchy of categories or very common kinds of objects. And that hierarchy of categories included way more things that what named entity recognition would be able to extract. So it would have documents, it have music, it have artists, it have videos, it have movies, it had TV shows, it had books and authors and sticky notes and other things. And in general, if you would look into encyclopedias like Wikidata, Microsoft Concept Graph, DeepPavlov, Google Knowledge Graph, Alexa Information Graph, and so on, all of them have lots of different types of entities. So this is the reality. Like all Alexa Prize teams, they usually have some sort of a knowledge graph or multiple knowledge graphs powering their solutions. And they also add some domain-specific databases like Rotten Tomatoes, IMDb, IGDB, Last.fm, Spotify, and so on. And they also link those items from them to each other to build even larger world graph of knowledge. In our case, we used our QBQA component, which is itself a mechanism that's capable of answering natural language questions about different kinds of facts, and then it transforms those queries into Sparkle queries, and then it returns responses from the database like Wikidata. But the important thing here is that you need to have a specific named entity recognition approach that would allow you to capture those kinds of entities that go beyond the classic people, organization, location, event kinds or tags in entity recognition. And fortunately, we used named entity recognition technology trained on top of Squad dataset. So it can recognize lots of different entities coming from Wikidata, and that allowed us to find those kind of entities. So this NER is designed very differently. It just can say if a given phrase has entity or it has no entity. So unlike classic NER, it doesn't distinguish kinds of entities in the text. It just says whether there are entities in the text or there are not entities in the text. And this allowed us to actually find those kinds of entities, and we use them a lot in our Express for Social Bot. So we didn't, however, build this whole graph at the scale as shown in this image here. But we still used this knowledge graph based on just Wikidata itself a lot in our Alexa Prize for Social Bot. Nonetheless, the idea that we proposed in our Alexa Prize for application, and that we wanted to propose an Alexa Prize for application, but we didn't, was that we could actually build a larger whole graph. So not only we could import data from different databases and then link them to each other, but we could also grab data coming from frequently updated sources. In the end, we used GNews API to grab fast news, get fresh news about the world. And the ideal idea was, like, if you have an item that user is mentioning, that we could then just use this news API to find news about this entity, in addition to whatever we can obtain from Wikidata. And while we didn't do things the way proposed here, like one large graph, we have done something with a similar effect. So for let me probably show it to you in the browser. We've created a specific annotator in our architecture that allows people to get Wikidata information about a particular object. So this is a Wikidata parser. And it will provide you information with a wiki parser annotation in this form. Let me try to find this on pretty online. Find some formatter. Let's put it this way. Process. And okay, this is how it's going to look like. Let me put it this way. So it would give you some sort of information about objects. And look what it's actually being able to find. It can have genre, it can have quality, it can tell us what the instance of what kind of entity this particular entity is. It can say data like publication date, and it can also cover topics if there are any topics related to this particular entity, and so on. And this is just an example. So over the time, we continued requesting more and more annotations from Wikipage parser. So in the end, every time we've got information from a user, we would use our squad trained NER to find entities. Then we would go into entity linking to look up entities in Wikidata. Then we would pass this information to Wikiparser that would extract this rich subset of information coming from Wikidata and annotate this data in the whole process, and then make this data available to skills, so that skills could use this richness of information to provide more engaging and interesting response back to the user. Okay, let's go back a little bit to the slides. Another thing that we could use but we didn't use was, it's not just even a thing, it's the idea that we could use this link, like also known as, which is basically used as a foundation for linking different knowledge graphs with each other to have this information about an entity. But as I said, in our case, we didn't use this as in our world knowledge graph. Instead, we used the annotations from Wikiparser. Now, our news API was called every time that a user said anything. So for whatever entities we managed to find from the user, we would make a lookup into the news API and add those annotations to the system as well. So that particular skill would be able to use latest news from the news API about the particular entity. And we also had some caching for news, so we did not make queries to news API at every single user utterance, but we would make this lookup only if there are no news about this particular entity, or if the time when the news were obtained was too long ago, and we have to grab new fresh news. And this entity linking itself, it's a model that precedes Wikiparser in a way. And as you can see, it's quite interesting. As I said before, we don't have NER that has classic entities like people, organizational, location, events. Instead, we use this quad-trained NER. And here we have grabbed an object called moon. And as you can see, it not only found a substring, we could extract all of this data. And this is a very basic component that you can grab like today. And you also can grab Wikiparser annotator if you want from our repository of DeepPavlov Dream, which is available at GitHub deepmip/dream. And that's about it for today. I hope that you will enjoy watching this recording. Feel free to ask any kind of questions in Twitter or in our forum at forum.deepavlov.ai or in our Telegram group. And see you next time in our community calls or in our other events. Thank you very much and goodbye.